So recently you went over adding and subtracting polynomials, and you've also reviewed vocabulary for polynomials. So now we're going to talk about multiplying polynomials. And in the beginning, it's really just the same thing as the distribution that you're already familiar with. You would multiply 4 to both terms and you would get 4x minus 8. That x really has an exponent of 1. But it's going to get more complicated than that. For example, you look at this next one, I have a negative 6x that's being distributed into this entire polynomial. This is a big polynomial. It's got 4 terms, leading coefficient of 3, degree of 3, constant term of minus 2, and it's in standard form because the exponents are going in descending order. Well, to get this distribution, you need to make sure that you remember your exponent rules, so we're going to take a quick break to review those exponent rules. The exponent rules you really care about for the multiplying of polynomials are basically this. Take your coefficients and multiply them. Add your exponents. You don't have to have like terms to multiply. You couldn't add these two because they're not like terms. You couldn't subtract these two because they're not like terms, but you are allowed to multiply. So down here is the exact same concept as up there, except it looks deceivingly easy or different. Remember that this is really a 1x to the first power. There's a secret 1 and a secret 1, just like there's a secret 1 right there. So now it's the same thing. I multiply x coefficients and I add exponents. So that's the exponent rules related to multiplication that you're going to need. Down here below, just as a reminder, I have listed the other exponent rules. Anything to the 0 power is 1. When I divide, and a fraction is dividing, I subtract exponents. So 8 minus 2 is 6. And if I have a negative exponent, it can go to the other part of the fraction as a positive exponent, and everything else stays the same. Okay, with that refreshing review of exponent properties, now go ahead and take a look as I multiply. The negative 6 times a 3 is negative 18. That's really an exponent of 1. 1 plus 3 is 4. That type of property is done on every single one of these along the way. Be careful, when I have negatives and subtraction, they combine to be positives, and that's easy to mess that up. So basic distribution, high-powered distribution, but now let's move on to something that's a little bit perplexing and probably new. This is multiplying. Remember, if I don't see anything between there, it's multiplying. But all of a sudden, we don't just have one item or one term that's being multiplied or distributed in. We have an entire x minus 4 times an entire x plus 7. So there's going to be 2 ways that you might want to look at this, and I'll show you both, and then you can just figure out which one you prefer. They're both really going to lead to the exact same answer. The first way somebody might look at this is called FOIL. And FOIL is just a neat little term that stands for first, outer, inner, last. And what that means is, if I look at each one of these binomials, I have a first term. Then I also have outer terms. The x and the 7 are outer terms. I have inner terms. 4 and the 6 are inner terms. And then I have last terms. 4 and 7. So this will be the order in which I go ahead and multiply. I multiply the first terms. X times x is x squared. Now I multiply the outer terms. X and 7 are outer terms. So x times 7 is positive 7x. Now I go to the inner terms. A minus 4 times x is a minus 4x. I've done the inner term, and now I do the last terms. The 4 and the 7 are last terms, and I get a negative 4 times positive 7 is negative 28. So I've done the first, outer, inner, last, FOIL. First, outer, inner, and then last. First, outer, inner, last. As soon as I have that, my very next step is just to put together like terms, because there's a darn good chance you're going to have like terms, and 7x and minus 4x are, so I would have x squared plus 3x minus 28 for my answer. So that's the method called FOIL. Another way I see this described, and what works for me, is called double distribution. So I'm going to redo this problem using the idea of double distribution. So I've recopied the same problem right there, and now I'm going to use double distribution. In my mind, double distribution says this: you take the x and you distribute it to both terms. So what I would have is x squared plus 7x. The x got distributed to both terms. Then you take the minus 4 and you distribute it to both terms. So then I would get a minus 4x minus 28. So the reason I think of that as double distribution is I just simply take this term and I distribute it, giving me two terms. Then I take the other term and I distribute it, and I've got that. So double distribution or FOIL, whatever method you prefer, they're going to give you the same thing. So take a look at this, take a look at this, they're identical, and then I would put together like terms, x squared plus 3x minus 28. Same answer there as I got there. So you go ahead and use double distribution or FOIL, whatever you'd prefer. So here's a problem right here, and I suggest that you pause the video, you multiply this out on your own, and you see if you get the same thing as me. That will let you know if you really understand what's going on here. Hopefully you paused it and gave it a try, because there's a difference between looking at what someone else did and doing it yourself. But I like to think of this as double distribution. The 3x gets multiplied to both terms. Then the minus 2 gets multiplied to both terms. And then normally after you do that, you have some like terms in the center, and I do. So I put them together, and there's my final answer. These final two problems are a little bit of kind of twists on what we've learned. This first one is x minus 4 squared. By the way, a very popular and absolutely positively wrong thing is people believe they can distribute the exponent into there. That is very naughty, and your dog will not look you in the eye for the rest of your life if you do that. X minus 4 squared, the first thing I would do is I would rewrite that to be x minus 4 times x minus 4. Now why am I doing that? Here's why. Think of this. When you were learning about squared, if you were asked what's 5 squared, what went into your mind is 5 times 5. If you were asked for negative 3 squared, what went into your mind is negative 3 times negative 3. So if you're asked for x minus 4 squared, what should go into your mind is x minus 4 times x minus 4. As soon as you do that, you've just changed this problem into a problem like we've done earlier, and now you can do your double distribution. This x gets distributed to both terms, x squared minus 4x. Then this minus 4 gets distributed to both terms, minus 4x plus 16. Very frequently there's going to be like terms on the inner two terms, so I get x squared minus 8x plus 16, and I have my answer. So when you see something squared, don't distribute the exponent. Your dog will never look at you again. Instead, just rewrite it. And this very last problem, this one's different because it's a binomial times a trinomial. Examples like this are why I would not like to think of these types of problems as FOIL, because FOIL, first, outer, inner, last, only really works with a binomial times a binomial. But double distribution will always make sense. So basically I'm going to take my x, distribute it 3 ways. So when I get that, I'm going to start over here because there's going to be a lot of writing. 3x to the third plus 2x squared minus 4x. And because this one's going to get a little bit cumbersome, I'm going to use a different color for the second part of my double distribution. Now I distribute my 2, so I get plus 6x squared plus 4x minus 8. When I do that, I've got a mess. I've got to really look carefully for my like terms. 3x to the third has no other term in it that matches up because there's no other exponent of 3 term. So for my final answer, the 3x to the third is just going to stay put, meaning it doesn't combine with anything. But the 2x squared and the 6x squared, those are like terms. They would combine to be 8x squared. The minus 4x and the plus 4x, those are like terms. Now in this case, by coincidence, they add to 0. Negative 4x plus 4x is 0, so I'm just not going to write anything. And then finally this minus 8, it's a constant term, and there are no other constant terms to be its like term, so it's all alone. And we get that for a final answer. This has been Multiplying of Polynomials.